Welcome to EDU World Space.
Hi. Here in this given problem, these four resistors are representing the four bulbs, four lamps in a mixed grouping. Along with a cell, a battery, providing EMF E. This is the resistance R1, R2, R3 and R4. And all these resistors are having same value. R1 is equal to R2 is equal to R3 is equal to R4, and all these are 4.50 ohm. The battery voltage, this is 9.00 volt. In the first part of the problem, we have to find current passing through all these four lamps. So first of all, these three R2, R3 and R4 are in parallel. So as R2, R3 and R4 are in parallel, three resistors are in parallel and all three are identical. So their net combination, in parallel combination, their value Rp, it will be given as either of the three, means R2, and divided by the number, and that is 3. So this is 4.50 ohm divided by 3 means it comes out to be equal to 1.50 ohm. Now R1, that is in series with this parallel combination Rp. So equivalent resistance of this combination, that will begin by R1 plus Rp, means this is 4.50 plus 1.50 ohm, and it is calculated to be equal to 6.00 ohm. So current passing through this combination, that will be using Ohm's law, it will be given by epsilon by R. R equivalent means this is 9 divided by 6, or we can say total current entering into the circuit. This is 1.5 ampere. Now, as current remains the same in series, so current passing through R1 means I1, that will be equal to total circuit current, means 1.5 ampere, and as it is divided in parallel combination, and all the three parallel resistors are identical, so we can say I2 will be equal to I3 will be equal to I4, and that is 1.5 divided by 3. So all these three currents are calculated to be equal to 0.5 ampere. So these are the answers for the first part of the given problem here. Okay, now in the second part of the problem, we have to find power dissipated as heat across these bulbs. So starting with P1, that is I1 square R1, means square of 1.5 multiplied by 4.5. So this P1 is calculated to be equal to 10.125 watt. And across other three bulbs, as these are in parallel and identical, so P2 will be equal to P3 will be equal to P4. Current in them 0.5 each square multiplied by the resistance 4.5 each. So P2 is equal to P3 is equal to P4, calculated to be equal to 1.125 watt. So these are the answers for part B of this problem. Now in the third part of the problem, now R4 is removed, one of the bulb that is removed, leaving behind only R2 and R3 in parallel. So when R4 is removed, now parallel combination, it will be having only two resistors. So formula will be 4.5 divided by 2 only. means this is 2.25 ohm. So equivalent resistance now again R1, which is 4.5 plus 2.25, and it is calculated to be equal to 6.75 ohm. So circuit current, which will be equal to current through first resistance I is equal to I1, and using Ohm's law it will be given by E by R equivalent again, means 9 by 6.75. So this is 1.33 ampere, and it will be divided into two parts now. So I2 will be equal to I3, means 1.33 divided by 2, and it is calculated to be equal to 0.67 ampere. So these are the answers for the third part of the problem. Then in the fourth part of the problem, we have to find power dissipated for the first bulb. P1 is equal to I1 square R1, means square of 1.33 multiplied by 4.50, calculated to be equal to 8 watt, means its power is reduced. And then P2, that will be equal to P3, means square of 0.66 multiplied by 4.50 again. So this power comes out to be equal to 2 watt each, means it is increased, because earlier it was just 1.125 watt. So it has been increased. So finally, in the fifth part of the problem, the brightness of R2 and R3 increases while that of R1 is being decreased. So here brightness of R2 and R3 is increasing. The reason is that earlier the current was being distributed in three bulbs, among three bulbs, so less amount of current was passing through each bulb, and now it is being distributed among only two bulbs. So more current is passing through them, and through R1 bulb R1 the power is decreasing. As overall resistance is increasing, means current is decreasing. Thank you.